We're supposed to factor 3x squared plus 4x minus 15 using two different methods, the factor by grouping method and the common factor quotient or CFQ method. Now both of these methods are called AC methods. And that's because they both depend on looking at the product AC. Now A is equal to 3 here, B is 4, and C is negative 15 using the usual notation for quadratics. So AC is 3 times negative 15 or negative 45. My goal is to find factors of AC that add to B, which is 4. So if we think about factors of negative 45, we could do negative 45 times 1, we could do 45 times negative 1. Neither of those is going to have the right target sum. What if we consider negative 9 times 5 as our product? If we look at the sum of those, negative 9 plus 5 is equal to negative 4, and that's almost right. Actually, what we want is b equal to positive 4. We got a negative, so the right thing to do is to switch those around. We'll do 9 times negative 5. That gives me the right product and the right sum. 9 plus negative 5 is equal to positive 4, and that's going to work out for me. So what I'll do from here is I'll rewrite, now using the factor by grouping method, I'll rewrite my original quadratic as follows. I'll put the n's in place, the 3x squared and the minus 15. I'm going to split that middle term 4x into two terms. I'll say plus 9x and minus 5x, where the 9 and the 5 come from these factors of negative 45 that I decided to give me the right target sum. So all I've done is split that middle term, that 4x, into a sum that's going to work out to give me the correct factorization. Now what I do is I group. I look at the first pair of factors and I see what I can factor out, what's common to both of those. I see that a 3x is common to 3x squared and 9x, so I'll factor that out. What's left then is an x plus 3, and notice that if I distribute the 3x back 3, I will get back to those original two terms. What's common to the second pair of factors is negative 5. If I factor out a negative 5, I would have an x plus a 3. And the reason this method now is successful for factoring is that I have a chunk of x plus 3 and another chunk of x plus 3 that's a common factor for each of the two terms that's left. So if I factor that x plus 3 out, what's left in the first term is a 3x. What's left in the second term is a negative 5, and that gives me the factorization. And of course, by multiplying this all back out, we could verify that that is truly equal to the original quadratic. And so this is the factored form. On the other hand, if I want to use the common factor quotient method, the setup, the initial part is precisely the same. I think about this as my scratch work. I find the AC, I look for factors of AC that add to B, and it would again be 9 and negative 5. What I do then to finish it up is I set up the problem a little bit differently. We write, starting with 3x squared here, we recognize that was the first term, and we'll just write 3x and divide by 3. And notice what that does when I multiply this back through. I'd have 9x squared, but the division by 3 corrects that 9x squared and makes it a 3x squared, which is my first term. So I know now that my first term will be correct if I set it up this way. My job now is to use the factors of A and C that I obtained here that added to B and put those in place. I'll do plus 9 because that was my first factor of negative 45 that I decided to use, and I'll put minus 5 here. Again, matching those, what I found with my AC scratch work. And then I just look to see what factors are common to each factor. 3x plus 9 has a common factor of 3, so I can factor 3 out of there, leaving an x plus 3. In this case, the 3x minus 5 second factor has no common factors between its two terms, so I'll just leave that. Often you'll have to factor something out of this the second factor as well. In this case, that's not necessary. Keeping the division by 3 where it was finishes this up. I just need to now reduce. In every case, when you're doing a common factor quotient, whatever you factored out of the first factor together with anything that might have been factored out of the second factor should multiply together to give you the denominator, and those will all cancel out, leaving you with the factored form of your quadratic. So both of these methods are really variations on a theme. They're variations on this AC process. They're just organized a bit differently.